Hello grade 12s and welcome to another physical science lesson under the topic of mechanics. Right now we're going to be dealing with work. Here we go. So the important information that you need to know are the formulae. Work is equal to force multiplied by displacement times cosine theta. Right. Theta is usually 0, right? And then for friction, theta is 180 degrees. And then the net work is equal to the change in kinetic energy. That's the work energy theorem. And then the net work is equal to the net force times the displacement times cosine of theta. This one is derived from this one. Okay. So all formula on the information sheet. Not sure about this one though. You might do well to take it down. Please take that down. I modified it from siavula.com. So number 1 states a car of mass 875 kilograms starts from rest and covers a distance of 600 meters in 75 seconds. So if you had a diagram, it would be something like this. The mass is 875 kilograms, right? Starts from rest, so the initial velocity is 0 because it starts from rest, right? And then from this point to this point, delta x is 600 meters, right? And then the time taken, 75 seconds. So 1.1 states, calculate the final velocity of the car after it has covered the given distance. So we have the initial velocity, delta x, delta t. So we're going to say Vf plus Vi over 2 delta t, right? This delta x, 600, is equal to, we don't have Vf, plus Vi is 0 over 2, delta t is 75. Divide both sides by 75, so 600 over 75. Vf plus 0 is just Vf, Vf over 2. The 75 cancels the other 75. So 600 over 75 is 8, right? So Vf is 8 times 2. Final velocity is 16 meters per second in the original direction. That's correct. 1.2 states, calculate the acceleration of the car as it covers the given distance. So acceleration, can use this formula. That's delta x, 600, Vi it's 0, delta t is 75, plus half, what is this? We don't have a, delta t is 75 squared, right? 600 is equal to 0 plus 5625 over 2. Over 2a, right? So a is going to be 600 times the reciprocal of this, 2 over 5625. Sixteen over 75, which is 0.21 meters per second squared. So therefore the acceleration is 0.21 meters per second squared in the original direction. Okay, let me just do my yes, Yes, that's correct. 1.3 states, calculate the weight of the car. The information sheet of the formula, weight is mg, which is, what is the mass? 875. G is 9,8. 8,575 newtons downwards, because weight acts downwards. So here we have chosen in the original direction and downwards as positive, right? So it means anything that's negative, it's either in the opposite direction or upwards. 1.4 states, calculate the net force acting on the car. So, formula F net is equal to MA. What is M? 875. What is A? You can take 0,21 or you can take 16 over 75. Whichever one you take will be accepted. .75 newtons. It's positive, so in the original direction. One 1.5 states, calculate the net work done on the car. Here, let's use the work energy theorem, right? Final kinetic energy, which is half m v f squared minus v I squared. M is 875. What is Vf? 16 squared minus Vi is 0 squared. Squared, 256 minus 0 is just 0. And 12,000 joules. So even if you had used the work net is the net force, which is 183, times delta x, which is 600, times cos 0. It would have been just different by one margin because remember here there's no rounding off. We took the velocities as they are, but here there's rounding off because of the net force. But I still hope that makes sense. And then 1.6 states, calculate the normal force acting on the car. Normal force, which is Fn, or N, is negative mg, or negative weight, which is negative 875 times 9,8. Negative 8575 newtons. So the normal force is 8,575 newtons upwards. I hope that makes sense. Number 2 states, a box of mass 8 kilograms is pushed from rest. It's pushed to the right from rest across a horizontal surface over a displacement of 12,5 meters in 5 seconds. Okay. If we had to have a drawing, it would be something like this. Mass is 8 kilograms. Yeah? We know that a force is applied. This is the applied force. Don't know how much is it, right? From rest, we know that the initial velocity is 0 over exactly. And then we are told that it's over a displacement of 12,5. So let's do it from here to here, right? It's horizontal. Meters. And the time taken is 5 seconds. That's what we have. Roman numeral number 1 states, determine the velocity of the box after 5 seconds, right? Once more, delta x is equal to Vf plus Vi over 2 delta t. Delta x is 12,5. Vf, we don't have it. Vi is 0 over 2. Time taken is 5. Divide both sides by 5. 12,5 over 5 is equal to Vf plus 0 is Vf over 2. 12,5 over 5 is 2,5. Vf is 2,5 times 2. Vf is 5 meters per second to the right. This is right because it's going this way, right? And then Roman numeral number 2 states, determine the momentum of the box after 5 seconds. So momentum P is equal to mv, which is, what is the mass? 8. What is the velocity after 5 seconds? 5. Therefore, momentum after 5 seconds is 8 times 5 is 40 kilogram meter per second to the right. Roman numeral number 3 states, find the acceleration of the box after 5 seconds. Once more, okay, let's use Vf is equal to Vi plus A delta t. Vf we calculated it to be 5, Vi is 0, A delta t 5. 5 is 8 times 5 is 5a, 5a plus 0 is 5a. Acceleration is 1 meter per second squared to the right. I hope that makes sense. Roman numeral number 4. Calculate the net force acting on the box. F net is equal to ma. What is the mass? 8 kilogram. This is the acceleration, 1 meter per second squared. The net force, 8 newtons to the right. I hope that makes sense. Then it states calculate the network done on the box. You can use that formula. What is the network? 8 delta x, the displacement is 12,5. Then we have cos 0. The network is 100 joules. Or we can use the change in kinetic energy. Half m is 8, Vf is 5 squared minus Vi is 0 squared. Still get to the same answer. You see, here we get to the same answer because the net force is a whole number, right? So I know there was a question about the average impulse, but you'll deal with that. I'll give that to you in the memo. Okay. If you found this helpful in any way, please click the like button and subscribe for more content. I hope that wasn't too challenging, and I hope to see you again. Thank you very much.